Hi, this is Kumar. Welcome to PVC channel, Department of MCA. This is Kumar. Today I would explain queue. Queue is like a stack, and queue is a linear data structure which follows a particular order in which the operation are performed. The order is first in, first out order. That is also called FIFO. FIFO is in a first in, first. The difference between the stack and the queue is in removing. It means the stack we remove the item the most recent added. It means top of the stack element is the deleted. And one more thing, the stack it can perform the operations only one end. In queue, we remove the item the least recently added. It means the queue, the operations perform two ends. It means one end is the front, another end is end. The operations can perform the two ends. The stack is only perform only one end only. Okay. And the operations associated with the queue in mainly four. In this, the first one is empty. The empty is nothing but it is a queue is empty. The other one is full. The full means the queue is full or not. And main important two operations, the dequeue and unqueue. It means the dequeue operation using for the removes the element from the front side of the queue. Dequeue performs using for the removing the elements. It can perform front end, front side, and unqueue it means the insert queue. It means the elements are added in the end of the queue. It means, for example, queue in this way, it is a queue. For example, it is in a front, it is in a end. The unqueue, the elements are added in end of the queue, and dequeue performs the removing elements in front end. Removing elements from front end, deleting elements in end position. Okay. The operations associated with the queue is the front and rear. That is the F and is the rear. The front pointer element responsible for the fetching the first element from the queue. Front is representing for the first element or the starting element of the queue. The rear pointer elements responsible for the fetching the last element for the queue. The same way, in case queue in one person like another person like another person like. For example, it's the front, it is in a end or rear position. It means it can enter anyone from the queue is the end of the okay. The first person is representing for the front, the last person is representing for the rear position. Next, some other real life examples. queue of people at any service points such as ticketing, etc. It means bus ticketing or railway ticketing in maintain the people in a queue order, or theaters is maintaining the queue, and queue of packets in data communication. It means in network data can flow one by one. That is also maintain the queue. And one more example, keyboard also using queue. It is the first entered character is its appears the first character. Another example, printer. The printer also maintaining the queue. Okay. Queue of the aeroplane waiting, landing, queue of processing in operating systems. Like so many examples, it's a for the real life. Okay. So it's a picture representing. It's in a maintaining the queue. For example, it's the front end. It's the first in, first out. It's in a rare position. It's the new one is entering the queue in the last position. Okay, like that. Next. So in algorithm, insert and delete. The insert unqueue and delete dequeue. Algorithm for the first of all, algorithm to insert item into queue. Okay. Here queue is an array n locations, front and rear points from the front and rear of the queue. Item is valued to be inserted. In the first position, if rear equal to n, then click var flow. It means rear is an end of the pointer. In case if the n value is equal to rear position, it's automatically it's the uh, full of the queue. That is representing for the rear equal to n. Else, in case the if condition is false, it's in a going to the else position. In this, again you can check the condition front and rear equal to 0. It means the first position of the queue or first person of the queue, that is set to front and rear equal to 1. Else, otherwise, in case second person you can enter into the queue, that is the else, that is the set rear equal to rear plus 1. It means the pre-incremented then uh, item to store in queue position at the rear pointer, using for the rear pointer. It means if we can using the insert, we can move pointer to rear pointer only. The inserted item are printed and exit. This is for the algorithm for the insertion. And another algorithm for the deletion operation. In this, you can check the queue is empty or not. In case the queue is empty, we cannot delete any operation. That's why first we can check the if the front equal to 0, it is an underflow. The underflow at the means is the uh, queue is an empty. Else, otherwise, item equal to queue front. It means it's representing for the front position of the element, it's stored to the item. Then, if front equal to rear, it means front position and rear position are equal. The simply set front equal to 0 and rear equal to 0. Otherwise, increment the front position. It means one person or one data are removed, so automatically the next person is the first person. That's why the front equal to front plus 1, the front value are increased, then item or deleted. The exit. Okay. This is for the deleting. The next, how to representing for the queues. The initially the front and rear positions are the -1 because of the any array indexing are starting from the 0th position, that is the indexing 0. That's why the initially the front and rear or the -1. In case you can enter any value the first position, that is the 0th indexing. So at present the empty queue is repeating for the front and rear equal to -1. The next, the first position insert the element, that is the 0th position. In this case, the front and rear positions are representing in same element. Because of only one element in the queue, so the first person or first element in the queue is the same as the end position of the queue. The next one, another element is inserted, the rear position are increased, is representing for the 1. They cannot change the front position. At the same way, in case insert the third, fourth and fifth elements, the rear position are increased. At present, the rear position are fourth element, the fourth indexing value. In this, the no deletion operation performed, the initially the first element of the representing for the front. In case we can delete or DQ perform the any operation, then it is moved to the front position. In this case, I perform the DQ, so the simply the first element are removed and the front position are moved to the next position. That is for the representing for the indexing 1, that is the value of 2. The same way, you can perform the second and third positions of DQ, the increase the front position. So now the front and rear positions are in the same value, that is the 4. Then again it can perform the DQ, that element also deleted. Again the initial values are -1. It means the no values in the queue, so it is representing -1 because of no elements in the queue. Thank you.